In this video, I will explain the difference between speed and velocity. But in order for me to do that, I need to tell you about Newton's first law of motion. So Newton's first law of motion states a body will remain at rest or move at a constant velocity unless acted upon by an external force. So what that means is if you bring a snooker ball into space, okay, well, in space there's no gravity, so if you leave the snooker ball there, it will just stay. It will just remain at rest. It won't move. It will just stay there. So Newton's first law here is saying a body. So a body in this case means any object. So it could be a satellite, a rocket, a snooker ball. It could be a golf ball. It could be anything, any object. So if you bring an object into space, there's no gravity in space, so it will remain at rest, meaning it won't move or anything, or it will move at a constant velocity. Well, velocity for the time being, just accept that velocity is like speed, but you have to take direction into account. So a body will remain at rest or move at a constant velocity unless acted upon by an external force here. Okay, so what that means is if you have a snooker ball in space, if you leave it there, if you bring a snooker ball into space, it will either remain at rest or it will. Well, if you give it a flick, let's say this is your snooker ball here, okay, and let's say you in space you give it a flick, so the snooker ball will move at a constant velocity. So it will move in the same speed and direction all the time, unless it is acted upon by an external force. So it will move. Let's say it starts here. You give it a flick, so it will move at a constant velocity, well, constant speed and direction. So if you give it a flick, it will move at a constant speed and direction, unless there's another force pushing on it. So by the time it gets here, let's say you give it another flick, but downwards. So it will change direction. It will go down in this direction. So in space, any object it will either remain at rest, or it will move at a constant speed and direction, unless acted upon by an external force. So if you give it a flick here, it will move it will move in the same direction and speed, unless there's another force acting on it, in which case it will change direction, or it will change speed. So here, if you give it a flick to the right, it will move at constant speed and direction. Now if I give it another bigger flick, it will go even faster. So there's a change in velocity. All right, it doesn't matter for the time being if you don't understand this velocity part, but just remember that if you bring a snooker ball into space, it will either remain at rest or move at a constant velocity unless acted upon by an external force. Now, what is this external force? What does this external force mean? Imagine, look at this here. Imagine you're on a boat, and this boat, well, a boat, and this boat has a pole stuck in. So normally there's a sail here, okay. So basically, I don't know what this is called. I think it's called a mast. I'm not sure, but imagine you're on a boat here like this. Now you see, if you stand in the boat and try and push this pole here, remember the pole is attached to the boat. The overall boat here, it would not move because even though you are pushing in this direction here, your feet are attached to the boat, and when you push against this pole, you are actually also pushing. Well, your feet are pushing back against, well, in this direction here. So overall, the boat would not move. Well, when I was young, I thought that if you're in a boat, you can actually push the boat in this direction, but it just wouldn't work because because you're also in effect pushing the other way as well. So overall, the two forces, they cancel each other out, and you can't actually do it. Or imagine, well, when I was young here, imagine this is a boat with a sail here. I thought that if you could attach a fan here, you could give it well, you could switch it on and then give it a push. But in effect, this fan here is attached to the boat. So this fan here and the boat is one entity, if you like. Is part of one being, the fan and the boat. So this here is not an external force. Now, if let's say there's wind blowing out here, you see the wind is not part of this entity here. The boat and the fan is one entity. So this here is an external force. Whereas this fan here is not an external force, because the fan and the boat is part of one entity. So this here, the fan here wouldn't be able to push the boat. Whereas if you have an external force here, you can push the boat. If you cut the bolt right here, let's say you cut up here, okay, so this here, this bolt here is separate from the fan here. So when you switch on the fan, in this case the bolt will move, because this bolt here is no longer part of this entity here. Now there are two separate entities now. So therefore the bolt is able to move. You see, up here, because you are inside the boat, you and the boat are one entity. So so this is not an external force. Even though you're pushing on it, it's not an external force, because you and the boat are part of one entity. So it's not external. Okay. So or also if you're in a rocket, suppose you're in a room, a small room within a rocket in space. Now you cannot move the rocket by pushing on the rocket, because you and the rocket are part of one entity. So it just wouldn't work. Okay, so let's look at this again. So hang on, sorry. So hang on, let me clear this. So Newton's first law states that a body will remain at rest or move at a constant velocity unless acted upon by an external force. So what that means is, hang on, what that means is, where's my snooker ball? Oh, never mind. Okay, so a body will remain at rest or move at constant velocity unless acted upon by an external force. It means that something in space will either remain at rest, or it will move at the same speed and direction unless there is an external force. Okay. Now come this bit here, constant velocity. What does that mean? Well, a body will remain at rest or move at a constant velocity. Now, constant velocity, constant means same, doesn't change. Okay, so a body will remain at rest or move at a constant velocity unless acted upon by an external force. Now, let's look at velocity here. Hang on. Let's say you've got that snooker ball. Okay, it starts here. 1 minute. Well, if you give it a flick in this direction, let's say it moves at 3 meters per second in this direction, and then a second later it moves in this direction. Okay. Now, is there a change in speed? Well, the speed here is 3 meters per second. The speed here is also 3 meters per second. So there's no change in speed. But the thing is that there is a change in direction, because it was, remember, you're in space. The snooker ball is in space. So in space it will want to go in a constant direction all the time. It wants to go in a straight line. But because there must have been an external force here to push it in this direction. Well, let's say the snooker ball is here. You flick it, it moves at 3 meters per second. And then a moment later, it still moves 3 meters per second, but in a different direction. So there's a change in direction. Okay, there's no change in speed because it's still 3 and 3. Now, whenever any of the two changes, then there's a change in velocity. So in this case here, there is there a change in speed? No, there's no change in speed. Is there a change in direction? Yes, there's a change in direction. Therefore, there's a change in velocity. Okay. There's a change in velocity. Wait there. Let's have a look at this one here. So let's say a snooker ball is here. It's moving 7 meters per second in this direction. Next minute, it changes. It's going 5 meters per second, but in this direction as well. So is there a change in speed? Well, it was 7. Now it's 5. So yes, there is a change in speed. Is there a change in direction? Yes, there's also a change in direction. So if any of these two changes, then therefore there's a change in velocity. Change in velocity. So velocity. Okay. So here there's a change in velocity. Let's have a look at this one here. Let's say the snooker ball is here. 1 minute is traveling 2 meters per second, and then the next minute it travels 9 meters per second. Let's have a look at this here. Is there a change in speed? Well, yes, it was 2, but now it's 9. So there's a change in speed. Is there a change in direction? No, it's in the same direction. Now, there's no change in direction, just a change in speed. So if there's a change in any of these two, then in this case, yes, there's a change in velocity here. Okay. Well, in space, if you have a snooker ball here, but by the time it gets to here, there must have been an external force to make it travel faster. So there must have, because there's a change in velocity, then you know that there must be an external force acted upon it. So it was traveling at 2, but then the next minute it travels at 9. Even though it's traveling in the same direction, there must have been an external force. Okay. So let's have a look at this one here. Now this one here, 3. Is there a change in speed? No, there's no change in speed. Is there a change in velocity in direction? No, it's in the same direction. So therefore, this is there's no change in velocity. So here this is at constant velocity. So here, if you have a snooker ball that's doing 3 meters per second here, and then another 3 meters per second here, because it's also in the same direction, there's no external force. So in this case here, this scenario here, there's no change in velocity. This is constant velocity. Okay, this one here, let's say a snooker ball is here, it moves here 1 second, and then the next second it moves 5 meters per second, but in this direction. Okay, is there a change in speed? No, because it's still 5 meters per second, and then here there's still 5 meters per second, so there's no change in speed. Is there a change in direction? Well, it was traveling in this direction, and now it's traveling in this direction. So there is a change in direction. So therefore, if you tick any of the two here, then there must be a change in velocity. So in this case, there's a change in velocity. So what that means is, in space, if you see something that's curling, let's say the planet Earth is here, okay? Sorry, let's say the sun is here. In space, things should travel in a straight line and at a constant speed. Now, if you see something that's curling like this, that means that there's a change in velocity here, because there's a change in direction. So there must be a force acted upon it. Well, in this case, in most cases, it will be gravity pushing against this all the time. That's why it's curling. So in space, things should want to travel in a straight line, unless it's acted upon by an external force. In most cases, it's gravity that's changing the direction. So here, if you have an asteroid here, it should travel in a straight line and at a same speed. It should travel at a constant velocity. Okay, but in some cases it curves around like this. So because there's a change in velocity, every time there's a change in direction, in this case there is with this asteroid, then there must be an external force. In most cases, it will be gravity pushing it, pulling it towards another body. Okay, so let's return back to the start here. So Newton's Newton's first law is a body will remain at rest or move at a constant velocity unless acted upon by an external force. Okay, so remember, so constant velocity. I hope you now understand velocity. Okay.